Labrīt, dārgie draugi, kolēģi, dombiedri, godātais rektori. Priecājos jūs sveikt 13. Kognitīvo zinātņu, loģikas un komunikācijas simpozijā. Good morning, dear honored guests, dear friends and colleagues. It's my great pleasure to welcome you to the 13th Symposium of Cognition, Logic and Communication. And the focus of this symposium is event and object perception. The way objects and events are represented in human perception, cognition, and language. And before moving to the first keynote and before moving to a couple of words, sort of telling you the rationale of this symposium and the underlying ideas, let me give the floor for some welcoming words from the University Rector of Latvia, Professor Indriķis Mužnieks.
Well, good morning, dear colleagues, good morning, participants of this conference, distinguished speakers, also supporters of and enablers of this meeting. I'm really happy to welcome you at the small aula of the University of Latvia in the year when we are celebrating a number of events and objects, centenaries. So we have celebrated the centenary of our country, Latvia, a month ago, and I'm wondering, so is it an object or perception or whatever, but by all means, university is an object, not only, of course, it's also an important instrument for and also notion for the development of our country, and we shall celebrate our centenary next year in September, and it is very, very symbolic. So we went because the name of the university, as you have already perceived, it's not the name of the city where it is located, as usually it would be for most of the universities in the world. It is the name of the country, and it just underlines the very intimate link between the development of those two perceptions, objects, Latvia and the university, because from the very beginning on, it was believed, and it is still so, that university should be the main driving force, this ultimate instrument for the development of the country, for social, cultural, research, life. And although the slogan of the university, which is not with it is, Scientia Patria, although it is to some sort contradictory in its essence, because science is, of course, international and has no borders, and Patria is very specifically defined place where we are living and thriving. It is essence also for the mission of the university, because we are trying to be, and our understanding is that without this international research-based dimension, the other part of our mission serving to the development of our country cannot be accomplished. And in this respect, for us, as for the university, which tries to be comprehensive and research-based, such events as your symposium are very important, and also showing as such light for the throwing light to the possible venues of our further development. And in this respect, I'm really happy that very different fields presented in our university, starting from medicine, ending up with philosophy and computer science, including they will be presented here, and this field of research, cognitive sciences, will be again in the focus of our discussions, because to our sincere belief that this interdisciplinary interaction, team science concepts and joint study concepts will be in the center of our further development. They will make the basis for the competitiveness of the university in future. And since we are now also in the process in the development of new university campus on the other side of the Daugava River, if you have time to visit the National Library, next block to this building, and this will be not just a place as a new campus with new infrastructure, but it will be just also the place for interacting, for bringing together many different study programs, many different research projects, which are now still scattered, but which we want to bring together as you are coming together at this meeting here. And I'm really happy and thankful to all of you who have arrived, who will participate, and especially to those who have contributed to the organization, to Jurģis Čilters, and also to those who have supported, to Accenture company, to our dear Mr. Blombergs, who will be supporting one of those distinguished lectures we shall hear today. And I wish you all the best mood, all the best experiences, and I hope that you will perceive Riga and this conference as an interesting and stimulating event for your academic life. So all the best.
Many thanks to University President. Well, before moving to the keynote, let me thank to our supporters, and we are delighted that our symposium is supported by several collaborators, several organizations like Latvian Child Neurology Association. I would like to thank Dr. Jurģis Strautmans in particular, then also Modris and Vali Galnieks from the United States of America, then software company Accenture, University of Latvia Foundation, and let me say a very special thanks to Robert Blumberg, the Honorary Consul of Republic of Latvia in Illinois, who has supported us morally and materially and established something that I would call a wonderful present to Latvian 100th anniversary, namely annual distinguished lecture in cognitive science. So this is something unique that you don't have in Estonia, Lithuania, and somewhere else in Eastern Europe. And on behalf of the organizers, participants, and program committee, many thanks for his support. And we are honored that Roberts is with us physically here, and I'm pleased to give the floor to him for a couple of introductory and a couple of welcoming words.
It's an honor to be with such a distinguished group today. I am here in support of my good friend, Dr. Jurģis Čilters, who I met in my hometown of Chicago a few years ago when Jurģis was visiting professor or visiting scholar at Northwestern University. And I was at the time the president of the Friends of the University of Latvia charity that's in America, and we look to raise funds to support the University of Latvia here. And I do recall, Jurģis, we had lunch, and it was very technical. I was a little out of my element, but I could tell how passionate Jurģis is about his field, and I am very interested in the field, but I probably didn't pick up all the technicalities of all the details that you guys discussed, because I'm a lawyer and not a cognitive scientist. But I was impressed with Jurģis's passion and mainly his sincerity and goodwill. As you guys all know, Jurģis is a great guy. And like I said, so I hope to learn a lot today. Like I said, I'm an attorney and I might struggle to follow everything along, but I hope to learn a lot today at the symposium. I believe what each of you is doing is very important. Many people are looking for help to understand how we think, why we make the decisions that we make. You help us to understand these things and a lot of other things. And for those paying attention to you, we can improve learning, gain professional advantage, or simply become healthier individuals. I wish you all an excellent symposium, and as I said, I look forward to learning new things. Thank you.
Thank you so much, Robert. And now we are almost done with the opening part, and many thanks to you all for coming, for supporting and organizing, and also thanks to the program committee, Michael Landberg, Alexis Wellwood, Susan Rocha, and Nora Newcombe, and lots of others have helped us to select papers, and that's a lot of work, and I'm happy that we are here, and I'm glad to wish you productive and fruitful 2 days and lots of inspiration in this conference. And now I'm happy to give the floor to Professor Jeffrey Zach from the University of Washington, St. Louis, who will introduce our first keynote, and the keynote that is co-funded by the Latvian Child Neurologists Association. So I'm pleased to give the floor to Professor Jeff.
Thank you, Jurgis. Amanda Woodward is the William S. Gray Professor of Psychology and Dean of the College of Social Science at the University of Chicago, where she's been most of her career since completing her PhD at Stanford, accepting a stint at the University of Maryland. Professor Woodward is a fellow of the American Academy of Arts and Sciences, the Association for Psychological Science, and the American Psychological Association, I believe Division 7. Professor Woodward, among many other distinctions, Professor Woodward's work, as we will hear today, aims to uncover how very young humans organize their physical and social worlds. It's characterized by exceptionally clear and incisive theorizing combined with creative and sensitive behavioral tasks. Speaking personally, her work on infants' understanding of goals and actions has been a major influence on my lab's thinking about event understanding for going on 2 decades now. Her title today is Action and Infant Understanding.
See if this works. Ah, very good. Great. Well, thank you very much. It is wonderful to be here, and so I want to extend my thanks for the invitation. Already beginning at dinner last night, we had wonderful conversation, and so these convenings that universities and events like this provide are just so enormously important for our thinking and the development of ideas in the field. I'm quite happy to be here. So I'm the first speaker today, and so thought we'd start at the beginning, sort of the beginning of life. So my research is focused on how it is that infants understand the world that they see. And of course, infants are enormously fascinated with the actions of people, of other people. And so really the driving question, or the driving set of questions, good? Yeah? Okay. In my research has been to try to understand what's going on in the mind of a baby like this one, who's looking at all of this busy human activity, and what meanings can they pull from it. In answering those questions, I've had to engage with sort of deep questions that have persisted in my field now for about a century about the nature of the infant mind, the nature of children's and infants' thinking. And so I thought I'd begin by giving you a sense, because this is a broad audience, of those kinds of questions, and then lead you through some examples from my laboratory over the years that engage those questions. So what's going on in the mind of a baby? How do we understand cognition in infants? There's sort of two prevailing views that have existed and continue to exist in dialogue with one another. One I think of as kind of the modern era in infant cognition, how a lot of people think about it now, which is that the minds of babies are very busy. The infant is thinking in quite sophisticated ways about the world, but because, of course, infants are so very behaviorally incompetent, it's hard for us to see it, right? So babies don't look all that smart in their day-to-day lives, but in fact, underneath it all, they're thinking in very abstract and complex ways. So the richness of infants' knowledge is sort of obscured by limitations on their actions. So these are views not just about infant cognition, but the relation of cognition to action in infants. A second view, and the older one, was first articulated by Jean Piaget, is the idea that action is central in development, and in fact, what babies have at the beginning is sort of only the ability to act in increasingly organized ways. They are not thinking in particularly abstract ways yet. So action is the beginning, it is the start of it all. Infants' knowledge is, in fact, limited to what Piaget called sensory motor schemas, or sort of intelligent ways of acting. And abstract knowledge emerges in this magical, transformative way in Piaget's theory from the baby's engagement and actions in the world. And I talk about these in terms of the modern era and the older view, but in fact, both of these views of infant cognition are active in the field, in my field right now, and in debate with each other. And every time the International Congress on Infant Studies gets together, there's a big fight about this, so we have not resolved this. And what I want to try to convince you of today is that both of these views have some truth to them. And that, in fact, infants' knowledge is abstract and generative in some ways early, but it's also the case that in infancy, like in much of life, abstract knowledge emerges from action, right? Action is a driver of new ideas and cognition in infancy and childhood. Okay, so for today's talk, I'm going to begin by talking about how do we even know what's going on in the mind of a baby, what are the kinds of evidence that we could use, and I'm going to give you a couple of examples that I hope will convince you a bit that infants perceive meaningful and relatively abstract structure in other people's actions. I'm going to present a few findings showing that, in fact, in infancy, this aspect of cognition, this aspect of thinking about events, is connected to and affected by infants' engagement in actions and their motor development. And then, if there's time at the end, I'll talk about what this might mean for infant thinking more generally, and how it is that infants' action knowledge and infants' actions in the world can be cognitively generative. Okay, so a lot of my work focuses on a very sort of what I think of as a fundamental aspect of events in which people act, which is that people's actions we don't perceive them just as physical movements through space, but we think of them in terms of what some folks have called intentional relations. We think about people's actions as being structured by relations to objects and other agents. So, for example, in this picture, you don't see simply two physical objects. You see two intentional agents who are connected to each other and to the world in particular ways. For example, you know this little boy is attending to something. There's something out there that he's indicating and attending to. You don't know what it is, but you know approximately where it is. And the fact of that relation is as obvious to you as the red and blue stripes on his shirt are. You don't have to think hard about it to see that. Even in this simple scene. So when and how do babies come to see others' actions in this way? How would we know that for somebody who's nonverbal and relatively limited in their abilities to act on the world? So a method that I adopted, I guess, now about 25 years ago in my work, is called visual habituation. And the idea is you show babies little plays or little movies, and you measure their visual attention, how long they watch the event. And babies, like anybody else, if you show them the same thing again and again and again, they get tired of it, they get bored with it, they habituate to it, and they attend less and less. And you can measure that. You can measure how long the baby looks. And then if you show the baby something new, and they notice it's new and they think it's an important difference, you'll see an increase in attention. And so in our early studies, what we did is we put babies in a little theater like this. We showed them events where people act in simple ways, in intentional ways, and then we measure how long they look over time, and we make some critical changes and see whether their attention recovers. That's our workhorse method for a long time. And I'll give you an example of how we employed that method. We showed babies as a start a really simple intentional action, an event in which somebody reaches out and grabs an object, right? That's what's depicted in the top line drawing here. Woman reaches into the stage and grabs the teddy bear. It's a really simple, really concrete event. Nevertheless, we think of it in our mature way, through mature eyes, as involving a relation between an agent and the object that is her goal. That is how we would describe it. We would use words like, even a simple description would be, she reached for the bear, she wanted the bear, so on. There are lots of properties of this event that we could perceive and remember about it, how the exact angle of the person's arm as it moved through space, how much of the arm was visible, the exact way the hand interacted with the object. All of those physical details we can describe, but they're not the ones that seem obvious and important to us, because this event is about the relation between the agent and her goal. And so essentially we wanted to ask if babies see it that way too. Is the relation between agent and goal the center of the event for infants? And so what we did is show them this same reaching for the teddy bear event again and again and again until they were bored with it. And then at that point, we reversed the position of the objects. And that allowed us to show them two events in a test phase. In one, in red here, the new goal event, the person moved her arm through the same physical path, but now there's a new goal. So this event disrupts the relation between agent and goal, but preserves lots of the physical features of the event. And the other event is just the converse of that. So the person reaches to the teddy bear, but now the teddy bear is in a different location. So the agent-goal relation is preserved, but lots of aspects of the physical properties of the event have been disrupted. And our question is just which of these changes is more noteworthy to babies? Which do they look longer at or show a bigger novelty response to? Do they respond in a selective way to changes in the intentional relations at play, or do they respond to the physical differences just as strongly as the intentional relations? And what we found over many studies over the years is that babies look longer when you change the intentional relations. They look longer at new goal than new side events in this study. We see this selective attention to intentional relations as early as 3 months of age in some cases, becomes quite robust over the course of the first year and changes in some interesting ways too. Importantly, this is a response that we see only in the case of human actions. So over the years, we've developed lots of comparison conditions in which we show babies similar events in which poster tubes move through space to contact objects, or mechanical claws move through space to grasp objects, or even cases in which people do strange and ill-formed things like dropping their hand on top of the object, something that doesn't look very intentional to adults. And in all of these cases, babies don't show this selective attention to the relation between agent and goal. They actually seem to do a more sort of uniform tallying of all the features. They'll respond to lots of dimensions of novelty, but not zoom in on the relation between agent and goal. Okay, so that's our first kind of evidence. When you do research with infants, it's always good to try to get converging evidence, right? So the research, the findings we get from visual habituation experiments have been enormously important and informative, but we'd like to know how robustly we see this kind of knowledge expressed in infants. And so in another line of studies, we used a very simple behavioral response that infants can perform, which is just reaching for and acting on objects. And what we asked is whether babies would show a tendency to imitate the goals of other people's actions. If you see somebody act, which pieces of that action are you going to reproduce? Findings with older children has shown that if they see a person engage in an action, older kids prioritize intentions and imitation. If they see somebody try but fail to achieve something, they'll imitate the supposed action that was attempted rather than the clumsy attempt that actually played out. And so we wanted to do a sort of baby version of this, and my collaborator in this work is a woman named Kylie Hamlin, who, when she did this work, was an undergraduate student at the University of Chicago. And here's what we did. We showed babies a person, like this woman here, and two objects, and the woman would do something in some conditions that was a goal-directed action toward one of the objects. In this case, she's reaching for the object, and we wanted to ask whether babies would, having seen that, selectively act on the object that had been the goal of her action, in this case, that green dinosaur. And we contrasted these conditions like this with conditions in which people did ill-formed things like dropping their hands on the object, or weird things like, reaching toward objects with sticks, things that we thought babies wouldn't see as goal-directed. And our question is whether, when babies see a goal-directed action and not in the other cases, do they typically imitate her goal or reach for the same object when given the chance themselves? I'll show you what this looks like. So here's a little baby. And you can see what he's seeing in the little corner there. He sees a woman. She's reaching for the red object. She calls his attention. She gives him a chance to reach, and he reaches for the red object. So that's the behavior that we're measuring here. And we just repeat that across trials. And what we find is that we've run these studies as young as 7 months, which is about as young as babies can do this behavior, reliably reaching for things. And what we find is that, just as in our visual habituation experiments, when babies see something that's a well-formed, goal-directed action, they tend to selectively act on the object that was the adult model's goal. When they see something that's not a well-formed, goal-directed action, they respond indiscriminately. They reach sort of equally to the two objects. And we've done sort of careful analyses of how babies are attending, whether they're staring more at one object or the other. And those effects seem not to be just a pure reflection of drawing attention to the object. It seems to be something about the baby's analysis of the event. Okay. A final way that we've looked at this is to use eye tracking to track how babies attend to events and anticipate events in time as they play out. So my collaborator in this has been Sheila Crowe-Jesperson, among other folks. Sheila is currently at Northwestern University. And so babies sit and they watch a little TV screen, and in the TV screen there are infrared light sources and infrared cameras that can compute by using reflected light off the baby's cornea where the baby's looking on the screen at any point in time. And babies see events that look like the ones I showed you before, where somebody reaches for an object at first, and then the object's positions switch, and now the person begins to reach but stops, and we just ask, will the baby visually predict where the person's going to reach? Will they predict that she's going to continue to reach for the same goal? And I'm going to show you what this looks like. This is an example of a baby, the replay of the data from a baby who was tested in this paradigm. The little red dot that you see on the screen is where the baby is looking. It's their point of gaze. By the way, these are fun experiments to run because parents love watching this gaze replay at the end. It makes them feel like they're looking into the mind of their infant. So we have that impression too. So here is a woman, and I'll just talk you through it. Okay, so she reaches for the little bear, and the baby's attending to that. Now the objects are reversed. She looks, she begins to reach. Baby looks at her hand, and the baby launches a predictive look, if you see, to the bear. Did everybody see that? Okay, that's the kind of data that we're taking in these experiments. So again, we're asking, of all the kinds of predictions babies can generate, will they generate ones that are about people's goals, right? And we've used this basic method in a number of experiments, and the findings generally look like this. So what I've plotted here is the proportion of trials on which babies generate a prediction to the prior goal versus the other object. So 50% would be random responding in these experiments. And you can see that in the blue bars, when babies see grasping events, they reliably predict the person's going to continue to reach for the same goal object. If they see an odd gesture toward the object, contact with the back of the hand, they don't generate a reliable prediction. They're random in their predicting. And then in another experiment, we did the same logic, but now contrasted reaching by a hand versus the movements of a mechanical claw toward an object. And in this case, we see again that infants selectively predict that the person will maintain her goal, and that they actually seem to make the opposite prediction for the claw. And the opposite prediction is that the claw is going to move through space in the same way it has before. That's a reasonable expectation for an inanimate object, right? If you have no other information, you've seen something move, say, to the bottom corner, you're probably going to predict that it's still going to move to the bottom corner. So these studies are providing more evidence or converging evidence that pretty early in life, babies are perceiving other people's actions in a unique way, in a special way, in a way that prioritizes intentional relations, right? Okay. I want to, so far I've just told you about pretty simple actions, reaching for things with your hands. It turns out that babies can apprehend somewhat more complex kinds of intentional relations, and here's one example. So here's an event in which two different agents have a goal in common because they're collaborating. And this is work that Annette Henderson did with me while she was a postdoc in my lab. So here's the way the event goes. There's two people, Lori and Annette. There's a toy in a box, and they're going to work together to get the toy out of the box. So Lori, the woman in red, opens the box. That's what's depicted there. And then Annette, the woman in blue, removes the toy from the box. So they performed different actions, they touched different things, but we understand that those actions were actually organized by a higher order goal that they share, which is about getting the toy out of the box. And so Annette and I wanted to ask if babies can perceive that higher order structure, and we did a series of visual habituation experiments that showed babies events like this. And the test event is, what about that woman in red? What was her goal in all of this? Now remember, all she ever did was touch the box, so you might think a low-level analysis is she's interested in boxes, but in fact we know she's probably interested in the toy, and so we show the woman in red, and there's a choice between the box and the toy, and on some trials she would pick the box, in other trials she'd pick the duck, and we look to see which babies find more novel. What we find is that by just after the first birthday, babies think that assume that she must have been going after the duck and not the box, and so they're actually surprised when she touches the box rather than the duck. I'm going to show you an eye-tracking version of this experiment. Same logic, but now we're tracking babies' visual predictions in time. Okay, so here are two women. They're very friendly. They like each other. Woman in blue is going to open the box. That's pretty exciting. They're thrilled. Then woman in red is going to retrieve the block. All right. Very happy about that. Okay. And then, oh, it's all great. Okay, so remember, blue has only ever touched the box. Now our question is, what is the woman in blue interested in? She begins to reach, she freezes, and then we look to see, in the baby in this case, oh, did you see it launched a visual prediction to the block? Okay, so we can look at it this way. Before I show you the data from the experiment, I want to point out an important control that we need to have in these studies, which is to really understand whether babies are thinking about collaboration in this higher order way. We need to know that they're thinking about the collaborative goal as distinct from just kind of actions happening at the same time, right? So we as adults understand that collaboration involves actions that are jointly instrumental to attaining a goal. We're collaborating when we do things that give us the same goal. And so we've had a number of control conditions that are similar to the events I showed you, but they're missing, critical pieces of what it would mean for it to be collaborative. And the one depicted here, the two women are there, there's box opening, and there's toy playing with, but one woman is just a spectator. She's like a fan at a soccer match, right? She's watching, but she's not really participating in the collaboration. The woman in red does all the work, and so that was our control condition here. And so our question is, will babies have reasonable ways of thinking about the woman in blue's goals when she's participated in a collaboration, and will those differ from what she does when the woman has just been an onlooker or an observer? And what we find is that in the collaborative condition, babies in general do what the example was that I showed you, they predict that the box opener, her actions are really about the object in the box and not the box itself, so they predict to the object. And babies in the onlooker condition are random. They don't generate systematic predictions. So babies seem to be, again, generating predictions about people's actions that come from a relatively abstract analysis of intentional relations, and that are, sort of taking into account the physical causal relations at play. All right. Great. So, first part of the talk, infants are smart. They detect intentional relations and others' actions. They apprehend relations that are relatively abstract, that structure the events in which people act. Okay. We see lots of different kinds of evidence for it. Over the years, so you might think, oh, great. I mean, nativist infancy psychologists would say, great, that's it. We've got full-fledged understanding of intentions from the beginning. But from the start of our research program, we noticed a few important things. One is that there seems to be change in babies' understanding of intentional relations across the first year of life. So by the end of the first year, babies understand a great deal more about intentional actions than they do early on. And we noticed that developments in infants' own actions are correlated with their ability to detect intentional relations in other people's actions. So we did a whole bunch of studies where we would bring babies in, measure their own abilities, say, to reach for things or to use tools to get to things, and then we measured their understanding of those same kinds of actions. And what we found is a correlation. So as babies get to be good at producing an action, they also get to be good at perceiving that action. That led us to do intervention experiments where we take infants who are not yet very good at a particular action, we support their engagement in that action, and then we ask if that generates changes in their understanding of other people's actions, so intervention experiments. It's helpful that babies aren't good at doing things in the first year because it gives us the opportunity to teach them. So I'm going to show you one example of a study that had this logic. It was a study that involved babies' understanding of means-ends relations, a little bit like the collaborative event I just showed you about. Here, the event involves a woman who acts on an intermediary. She pulls a cloth in order to get the toy that's on top of the cloth. And the question is whether babies can understand that the woman's actions are organized by this higher order goal of getting the toy rather than the cloth itself. And so we use this visual habituation logic to ask that. And what we had found in prior studies is that by about 12 months or so, babies spontaneously understand that about these kinds of events. 12-month-old babies are also reasonably good at means-end problem solving on their own. So what we did, and this is work that Sarah Gerson did in my lab, she's now at Cardiff, was we took babies who were a bit younger, 8-month-olds. 8-month-olds are not on the whole all that good at solving means-ends problems, but they're close enough that we can coach them and teach them, and they can get to be better in the course of a lab session. And so we looked at whether that training would have an effect on their perception of other people's means-ends actions. And so I chose this experiment because the videos from it are the most fun. So here's an 8-month-old baby in our lab, and this is before any training. There's this great duck, there's a wonderful, she would love to have, but she is not perceiving what she might do in the situation, plays with the cloth a bit, and then notices the duck, but it's a bit too late, and she loses it. Okay, so that's the before training state. Then the way we train babies in these studies is we just show them, this is how it works, and then we give them a chance to do it themselves. So here's this. The experimenter shows her, this is how this works. We pull the cloth, and then we can get the toy. Babies find this incredibly fascinating, really interesting to look at. Okay, now we'll give you a chance. Can you do it? I don't know, maybe? Yeah, a little bit of success. So babies get a few trials like that. And then these are post-training trials where it's just, we don't give them any hint, we just set up some new problems for them. And by this time, she's an expert. No problem. So in these experiments, it actually turns out that about half the infants we tested are like this baby. They improve. They can benefit from the training that we give them. And the other half, on the whole, didn't improve. It doesn't mean anything, I think, very durably interesting about babies. It's just that we're picking a moment in development where some babies are ready to benefit and some babies are not yet ready to benefit. And it turns out that their responses in the visual habituation paradigm, in the part where we tested their perception of other people's actions, varied as a function of how much they learned from the training. So babies who were what we call most planful, they're from your perception, the right bars there, those are babies who learned, who improved over the course of the training session and were like the infant that you saw. They showed a pattern of responses that was like older babies' responses in the experiment. They detected changes in the relation between the woman and the ultimate goal of her actions, and they prioritized those over the relation between the woman and the cloth. So they had this higher level interpretation of the actions. Babies in the same group who were not planful, who didn't benefit from training, actually showed the opposite perception. They seem to be thinking about the sort of concrete connections between people and objects, so they prioritize the relationship between the woman and the cloth. Okay, so these basic findings that we can intervene, and when we change babies' actions, this generates a change in their perception of actions. We've seen across a number of experiments. One of the first places we did this was using something called sticky mittens, which are Velcro-covered mittens that you can put on the hands of 3-month-olds. And 3-month-olds are terrible at reaching from grabbing objects, but they can swat at things, and they can learn that the Velcro enables them to pick things up. And it turns out that that experience generates changes in their responses to other people's reaching actions in the habituation paradigm that I talked about at the very beginning of this talk. We've done something like this recently where we train 9-month-old babies to use a tool. That's what's depicted on the bottom. It's a cane that you can pull to get a toy to come to you. 9-month-old babies aren't great at doing that spontaneously. They can learn to do it, and having learned to do it, it changes their responses to other people's tool use actions in that imitation paradigm I showed you. We have the same thing with practice in collaborative games for younger babies who don't spontaneously perceive the goal structure of collaborative actions. If they participate in collaborative games first, they get it. And finally, we have some new data with 8-month-old babies who are not that great at launching in-the-moment predictions about goal-directed actions. If they get to warm up by reaching for things first, they're better at launching predictions. Okay. So all of these findings suggest that acting leads to sort of smarter thinking about other people's actions, right? And a question that we had pondered for a long time is why. It could be something about, and the reason we think about it is because every reviewer of every paper we ever submitted thinks about this. Maybe in some way we're just, when you act yourself, you're more engaged, you pay better attention. Some sort of general attentional or motivational effects could be creating these results. You just get better performance when you're juiced up than when you're not. And what we'd be more interested in is whether there's some kind of interesting connection between the systems that are there to help babies be smart actors and the systems that are there to help us be perceivers of other people's action. Okay, so how can we tell these things apart? Well, in a maybe foolhardy way, I turned to developmental neuroscience. So I have a collaboration with Nathan Fox at the University of Maryland where we use EEG to try to gain further insight into the neurocognitive processes that are going on when babies are perceiving other people's actions. And Nathan and I and our collaborators we're interested in an aspect of EEG, electrical activity that occurs chronically, the sort of rhythmic or synchronous activity of the brain that seems to be related or seem to the production of action in adults and in babies, and also seems to play out in the perception of action in babies and adults. And that's sort of suppression relative to baseline in the EEG signal in what's called the mu band. So it's different frequencies for adults and babies, but it's been identified in various experiments that you see the same pattern in EEG activity when babies and adults are producing goal-directed actions and when they're watching other people produce goal-directed action. So we thought we'd look at this. In infants, there's some kind of nice data from Nathan's lab showing that the strength of this desynchronization response is related to babies' own motor development. So babies can reach for things by the time they're 8 months or 9 months or so, but there's still variation in how skilled their reaching is, and variation in reaching skill correlates with the extent of the desynchronization response when babies are watching other people's actions. So there's something about motor development at play here. Okay, so these findings, or up to this point, had suggested that that this response, this desynchronization in the mu band in infants reflects motor activity and motor maturity. But it's not clear whether there's any functional significance to this. It might just be that there's some kind of resonance or reminding that's happening. So is this activity actually related to being able to perceive goal structure in other people's actions in some functional way? That was our question. And this is a question that Courtney Philippi, a student who did her PhD with me and is now a postdoc at National Institute for Mental Health, was interested in asking. And so what we did is we collected EEG while babies played the imitation game. So I'll just show you the imitation game again so you remember it. This is a game where babies see somebody act on a toy, and then they get the chance to act on the toy themselves, and we look at whether they tend to act on the person's prior goal. What's nice about this paradigm is you can get babies to do lots of trials, and you can see why it's kind of fun. You just get toy after toy after toy, so they're happy and they're interested, and you just show a different set of toys on each trial, and you can get babies through enough trials that we could get reasonable EEG data from them. So here's the idea. Oh, the other thing that's nice about this paradigm is babies are variable in how they respond. So although they tend to, above chance, pick the goal object, there's a lot of, sometimes they pick that other object. And so we have trials both where they show a response to the person's goal and trials where they don't within infants. So we can use that variability in babies' performance to see whether EEG is systematically related to trials on which they did the right thing in which they attended to the goal. So we have a behavioral measure of infants' goal sensitivity, the extent to which they imitated the other person's goal, and we were able to ask whether neural activity as the baby is watching the woman, right? So baby watches the woman reach for things, what's happening in their brain as they're watching, and can that activity predict what their behavioral response is going to be, whether they pick the prior goal versus the other object? That was our question. Okay, we had 36 babies in the study. That was heroic for EEG experiments with infants, although, in the grand scheme of things, not that many. We included only trials in which the baby did two things. They watched the experimenter's actions, and then they reached for one of the two toys. So they produced a behavioral response that we could code. We took all of those trials, and then we binned the trials based on whether the baby went on to pick the adult's prior goal versus pick the other object. That makes sense? And our question is whether neural activity during observation differed as a function of what kind of behavioral response babies went on to make. Okay, and in this study, because we ran lots and lots of trials, we actually got about equal numbers of goal responses and non-goal responses, right? This was a harder, more demanding procedure for babies. They had to have the EEG cap on, and then there were lots and lots of trials, so at a behavioral level, they were kind of random in the end, but that was good for us because we had equal numbers of goal and non-goal trials. Okay, and what we found is that on trials where babies made a goal response, we saw significant desynchronization in the mu band, that response that's been associated with action perception. On trials where babies didn't, chose the other object, we actually didn't see any change, any reliable change in mu activity, suggesting that this response in the motor system is selective for cases where babies are tuning into other people's goals. We also looked at this sort of through a different lens in the same data. So we had trials where babies themselves were reaching for objects, so we're collecting EEG while they're reaching for objects, and we can measure the strength of that mu ERD response while they themselves are acting, and remember that's related to sort of maturity of reaching behavior. And then we can ask whether variation in that signal predicts on the whole how likely babies were to imitate the experimenter's goal, right? So sort of now I told you about it within subjects analysis. This is a this is a between subjects analysis of individual differences where we're asking whether variation in motor maturity predicts how likely babies are to pick the goal object. Okay. And it's a predictor. So what we have plotted here are the proportion of goal imitative responses, and on the y-axis, the mu desynchronization, which is a negative going tendency, right? And what you can see is that babies who showed bigger mu desynchronization also were more likely to pick the goal object. Okay. So variability within and between babies provides some evidence that there's this selective relation between motor system activity, as indexed by mu ERD, and behavioral responses to other people's goals. So this, I think, is as close as we can get to evidence in babies that there's a systematic relation between neural activity in the motor system and goal perception. Okay, so I have a little bit of time. I think I can get to the last bit before we go to questions. Infants see, just to wrap up where we are to this point, babies see intentional structure in the social world. This ability is shaped by their own actions and related to activity in the motor system. So this is a way in which concrete experience supports insights about abstract intentional structure in other people's actions. This causes great consternation because infancy researchers think if it's motor, it's not abstract. We get all hung up on that. And so I think we just have to rethink that assumption. And in fact, there are reasons to think that action is quite cognitively generative, not only generative in terms of insight into intentional relations in other people's actions, as I've been arguing, but in other ways as well. So we have looked at this in other ways. So what I'm going to talk about is event memory, because this is a meeting about events. So I'll just talk about that. So in adults, we know from adult studies of memory and narrative memory that other people's goals are really great organizers for memory. We remember information from complex events as it relates to other people's goals and intentions in a prioritized way that suggests that goal frameworks provide an important sort of substrate for memory. And so we wondered whether the same could be true for a baby's nonverbal perception of other people's goals. And as we began to think about this, we realized this really interesting thing, which is that in the infant developmental literature, where people have looked at the development of memory, the best evidence for long-term memory in infants comes from studies that are about memory for actions. Nobody ever really thought of it this way, but there's something called deferred imitation as a measure of memory, and that is where you show babies a series of events. In this one depicted here, it's building a rattle by putting a ball inside 2 cups, putting the cups together, and you shake it. You show them that event, then you send them away from the lab for a week or 2 weeks or a month or 2 months, and then they come back and you give them the pieces and you see what they do. Do they put them back together? And if they do, then you know that they've remembered it. And these studies have shown that babies have quite enduring memories quite early on. Months they can sustain these memories. And they're all, of course, memory for action. And so we wondered whether it's just a coincidence, or whether, in fact, the presence of an agent and of goal-directed action actually provides an important kind of support or framework for baby's memory. And this is work that Lauren Howard did in my lab. Lauren's now at Franklin and Marshall College. This is her dissertation work. So this was a great question for babies. We asked it first in 3-year-old children because it was so much easier to figure out how to do it in 3-year-old children. So in 3-year-olds, what we did is we showed babies step-by-step instructions. We called it the IKEA experiment because it was how to build things from parts. There's a set of pictures that depict how you build an object from pieces. And across conditions, the only thing that differs is whether there's a human present in the scene. And you can see in these still pictures, there's a person who sits behind or hands are on either side of the pieces, right? So there's no real information about action. There's just the suggestion that she's probably the one putting all this stuff together, versus in the non-agent condition, you see the same construction information, but there's no agent that might help you think of these things as all about a person's actions. Okay, I got to show you. This is a little girl putting, oh, we don't have audio, but I'll show you. This is a baby's, kids see these events, there's a delay period, they come back, and we say, hey, guess what? Here's some stuff. Can you put this together? And we see whether they spontaneously put things together. They're remarkably good at it, actually. Okay. Pretty good at it. Huh. That's a problem. Yeah, got to fix that. Okay. Actually, across all these experiments, an interesting thing is how well kids remember people's actions. It's a thing. Remembering actions is something that little kids are very good at, or pretty good at. So we get that right. Okay. Then we've got the ears. What do those do? And she's not sure. So if I don't have the audio on, but what she says is pants. And she thinks perhaps they're the pants. Okay, so memory isn't always perfect, right? So we just coded how many of the steps did kids produce appropriately, and across a number of experiments, what Lauren has found is that kids remember more steps when there was an agent in the picture than when there wasn't, right? And she even has some ERP findings, so we can see differences in memory even when it's not a behavioral measure of memory. The really interesting thing here is, of course, it's not due to something like overall attention. We did some of this with events presented on an eye tracker, because in fact, kids pay less attention to the object being constructed when there's a person in the scene, because there's something else to look at. So it's not just the extent to which attention is entrained on the object, something more complicated going on here. And then we've just recently done the same thing with babies. So this is a visual study, but babies see a tower constructed by a hand or a tower constructed by a mechanical claw. And then we just assess their memory in a visual preference comparison procedure. Babies, if you show them two things side by side, they'll look more at the thing that looks new to them than the thing that looks old to them. And what we find is that babies who see hands build things show a pretty big novelty response. They have robust memory. They look more at the new tower than the old tower. Babies who see a claw build things still show a significant difference. They're remembering, but it's less robust. Then we did our intervention experiment, because that's what we do. In this case, the intervention was the baby interacting with the claw rather than using the claw themselves. And then we showed them the claw tower builder, and now we get the big memory effect. So it looks like, again, the same kinds of signatures we've seen in other experiments. Actions that you yourself are good at are good cues for organizing things in memory, and training a new action can sort of instigate that way of thinking. Okay, so now I'm going to finish. So this is some evidence that action provides food for thought for infants. Infants thinking about others' actions is bound up with their own actions, and the connection is cognitively potent. Engaging in an action can help infants bring action analysis to bear in organizing events in memory. So to come back, just to remind you of what I was hoping to convince you of, is that babies' knowledge about other people's actions is abstract and generative in some ways, and that it's very much connected to and driven by and supported by and fueled by their engagement in action themselves. And so one of the things I hope that other infancy researchers will think about is there's a lot of infancy research that shows babies different kinds of events, events in which objects are occluded by other events, events in which objects act causally on other objects, events involving various kinds of intentional actions or the movements of sets of things. There's been a lot of focus on what babies do or don't know, but not much focus on how what they know might relate to what they can do. And I think there's a lot of open ground there. So thank you. I'll take questions. Rob, yeah?
So I guess I'm wondering how... Be loud.
Uh-huh.
So I'm curious about to what extent you could actually learn that something that was not like a human agent, like a claw, through enough association is the kind of thing that is goal-based. I guess I'm wondering from like a theoretical perspective, like how much is it this sort of hardwired association between humans and intentionality, but also from a practical sense. I'm also interested in if there's more learning by our children from robots and things like that.
Yeah,
whether
yeah.
robots can, with learning, be the kinds of things that these kids are going to assume are intentional.
Yeah, I think so. I mean, I think our findings suggest that babies and kids can learn, and they suggest the conditions under which they can learn. So collaborative engagement turns out to be I think a potent source of evidence for infants about intentional action. We've seen it in really simple baby experiments. So I showed just now the photo of the baby taking an object from the claw that in this case is used by an experimenter. So that's a case where the baby's not using the claw themselves, it's not their own action, but they're engaged in a sort of organized goal-directed action with the claw, right? That turns out to be a sort of potent manipulation for helping babies understand the actions with claw tools as being goal-directed. And I think by extension, you could see how that might work for something like a robot. So yeah, I think this isn't just a hardwired, I see a hand, I think X. It's not that way, because that's not the way human intentions are, right? They're much more complex and innovative, and so babies are built in ways that they can do that kind of learning, yeah. Yes, Chris? Yeah.
I have a question in two parts, really. The first part relates to your neurocognitive experiments, and my question there is, how do you relate this to findings on mirror neuron research and what Michael Arbib calls the mirror system hypothesis and imitative learning? And the second part of the question, and I think they are related, is that when you do training in means-ends activity and understanding of means-ends relationships, this is also kind of participative activity. It's collaborative.
Yeah.
So when you're talking about action here, I think in all of your experiments, actually, the action is itself an engaged action in a participatory role. Yeah. And maybe this is actually, this is slightly different from the Piagetian sensorimotor solitary infant stuff. And I wonder how you might relate those two bits of my question together. Yeah.
That's really great. Yeah, that's a perfect question. So you're right. The way that, let me start with the second one, and then maybe I'll try to get to the first. So the way that we train babies in actions is very social and collaborative, right? And so that is a way in which it's, the Piaget's view is the baby experimenter out there on their own, right? And this is much more socially embedded. And it might be that matters, that seeing the correspondence between your own actions and other people's actions is particularly easy if you've been acting with them in that way. Some new work from my lab that Marlena Meyer, who's a postdoc in the lab, has been spearheading, has looked at that mu response to other people's actions in two different settings. One is where it just had to do with, so in the study, babies had trials where they themselves reached for objects and where they watched somebody reach for objects. And we just varied the trial structures. So for one group of babies, the trials were blocked. So you got a bunch of perception trials and then a bunch of action trials and a bunch of perception and a bunch of action. And in the other group, they were interleaved. So it was like perceive, act, perceive, act, perceive, act. So that second one felt more collaborative. It felt more like a turn-taking thing. And we got a much bigger mu response there than we did in the blocked trials, sort of consistent with this idea that you're seeing it, when your actions are coordinated with someone else's actions, that's particularly informative for sort of bringing your own neurocognitive system for action into alignment with the other person's actions. So I think there's something there. The first question you asked, which is how does this relate to the whole mirror neuron literature, is a fun one, because my collaborators in this project, one of them is from the Parma group, Pierre Ferrari. He's quite a vocal advocate for all things mirror neuron, and we have lots of fun debates where, about what may or may not be going on. And Nathan Fox, our other collaborator, is just completely agnostic about whether any of this means anything. So it's a fun collaboration for that reason. I have no idea whether mirror neurons are involved in this, because we can't measure things at that level of specificity. And I'm not sure that it makes sense to think of individual neurons as having some kind of magic effect. The more interesting questions are how the neurocognitive systems that are there for the control of intentional action might be recruited or do some work for perception of action. And so, anyway, that's how I think about it.
Yeah. I think Arbib is now talking, he doesn't talk about mirror neurons in human development and specifically human cognitive systems. He's talking about a mirror system somehow, which maybe has emerged out of more specific neural circuits.
Yeah, and right. So I think that's the way to go, right? Yeah, yeah.
Thanks, very interesting talk. I wondered if you had thought about the way actions, whether this has any relevance to the way actions are encoded with objects. Everything in your movies were toys, which have some purpose, but I'm thinking about various levels of affordances, such as cups and knives and plates. Have you looked at the variance or the differences in the way children interpret the latent or implicit actions associated with objects, such as?
Yeah. It's great. I haven't. Those are great questions, right? Because artifacts, human artifacts, are about the kinds of actions we can do with them, right? So there's work that Sabina Hunius has done in her lab, looking at babies' perception of that. So she's done some work just asking whether babies can detect when you're using an object wrongly. So if you hold a cup to your head versus your mouth, and babies detect those kinds of mismatches from quite early. But yeah, I think that's an area that would be interesting to explore more. Yeah.
Hi.
Yeah.
So I was wondering about the last result, where you get the children are showing better reproduction of a series of actions when they have the visual agent as opposed to none. And I was wondering about this because so there's a sense in which the activity with the agent, is more complex. There's more stuff going on. There's more involved. But then, of course, you see that they're not actually even necessarily paying as much attention to that scene. But there's also a sense in which the rabbit, say, constructing itself is kind of unnatural. And so I'm just kind of wondering. I was trying to consider like descriptions that one might use of these scenes to kind of get at, okay, well, is there like a difference in like the naturalness of the concept that one might deploy in viewing these scenes? And certainly like Anne built a rabbit. Fine, and then okay, how would we describe the other one? Like the rabbit self-constructed, or
yeah. So
Oh well, I'm wondering if I think it's an implication of your talk that the effects have to do with really engaging like sort of the motor system, and it's like aha, I see how I would do it and that kind of thing. But I'm wondering if there isn't potentially a representational question there, and if not, I didn't get very far in this part of the thought, but if you were to take, for example. Like if you had some kind of scene that was more like the rabbit grew or the plant grew or something like that, so versus Anne grew the rabbit or whatever, but scenes that make those kind of causative or encodative concepts salient, whether you would expect the same thing or not, or.
Yeah, that's great. That's really great. So one thing I want to clarify is that these were still pictures. There's a whole piece of the developmental literature that does this thing called ghost conditions, where objects seem to move on their own as comparison where people move objects. And we were worried about that because you're comparing something that looks magical or impossible to something that looks real and familiar. And so that's why we use still pictures. And our hope was that, obviously if you thought hard about it, right, in the non-aging condition, somebody must have put the nose on the bunny, right? It's just that you're not making it salient. So we were trying to contrast a construal that was focused on what a person did, right, sort of facilitating that by just having the person in the picture, versus a construal that was about how the pieces of the object could fit together, which is, you can think sensibly about how objects can relate to each other. But you're right, maybe there's a richer way that we could show things that were essentially non-intentional, like something growing, right? Or coming together as a result of natural forces or something that would that might show similar kinds of organization. I think it's interesting. We may tend to think about those things in intentional terms. Those may be cases, in any case, where we use our intention concepts to organize events like that, right? If you think about how we talk about evolution, for example, okay, yes.
Any other questions? Okay, I see.
So that was awesome. I was thinking about your mean reviewers and about the mu suppression experiments, and so especially thinking about this as a neuroimaging person. So do they come back and then say, Okay, well, arousal leads to more mu suppression and also leads to understanding the hierarchical goal structure of the activity, but the latter is not causally mediated through the former.
Yeah. Yeah, they did, in fact. Exactly. Oh, it's all about attention. And we're like, no, we don't think it's about attention. But yeah, so, or what kind of attention, I guess. Yeah, you could. And ultimately, the findings we have with babies are just correlational findings, right? We're not in a place where we can intervene and, you know, with babies in a way that would give us more causal power. Yeah.
Yes, I was thinking, I mean, you're not going to TMS the babies, but maybe there's a behavioral intervention that could be kind of selectively aimed at blocking the motor part, but without.
Yeah, so we're doing our other kind of behavioral intervention now where we're training babies on a new action, so we're training them on that cane pulling, and then we're asking what kinds of neural changes to cane pulling that results in, so looking at whether it's sort of, and now we're going to look more at components of EEG that we know are related to attention, like frontal theta, and see how that activity relates to motor activity. You might expect to see both. It's interesting if we could look at them in time. That would be pretty interesting, and maybe we can do that. So these are things we're beginning to try to do now. Yeah. Okay.
Thanks. Are any other questions or comments or anything to add, to clarify? If no, then let's thank to our speaker again. It was wonderful. And now we are having a coffee break, and that's just the next room to the next adjacent room. And those of you who would like to sign up for conference dinner, please do it on the conference desk. Thank you.